Welcome to Dragonfly webinar. I'm Roman. I am the CTO of Dragonfly DB, and today I would like to Dragonfly Swarm, talk about its architecture and show and demonstrate its life in action and compare it maybe to other managed services. So let's start. So a bit of Dragonfly history, and I kind of explained it in our previous webinars, but really fast. I was a Redis user myself for a few years, couldn't quite get it right in terms of performance. We always had stability problems in production, couldn't do snapshotting under load, had various issues, and then I moved to be an engineer on the Elasticsearch team at AWS, and I saw that other customers, AWS customers, have similar problems, and maybe it's not us, but the technology. And I had this crazy idea that it is possible to re-implement in-memory data store in such a way that it will be more stable, more reliable, more cost-efficient, and still very, very fast. And I've pitched this idea to my friend, Oded, who became my co-founder and the CEO of Dragonfly DB, and this is how we started the company. And if we fast forward to today, Dragonfly is very prominent project with more than 27,000 stars, with thousands of teams using it across globe, with teams picking up the most recent features that we add. It's really, really exciting to see. The project evolves, and I am super excited that we launched Dragonfly Swarm last month as well as part of our managed service. Cool. So what was the kind of the primary thing that drove me to redesign memory store and release Dragonfly? So basically, as probably most of you know, Redis originally was single-threaded, which caused lots of stability and performance issues, especially at scale. And the only solution for that was horizontal scale and cluster mode. Now, with cluster mode, there are some limitations, and not all customers could use it. So we're basically stuck with a single-threaded application that they couldn't scale vertically. And with cluster mode, we have other issues like due to its limited CPU power, it could be very slow in resharding. Its shards could overheat and be unstable. And basically, customers that switched from other in-memory solution to Dragonfly always said that with Redis Cluster is basically the stability of it is the main issue. When they scale the workload to dozens of shards, usually some of them sporadically can stop working or start behaving in some funny ways. And that lack of stability is kind of not something that production teams can sustain. So the main issue with Redis cluster is lack of its stability, and when you scale it to large sizes, it can become very costly. I already talked about kind of single-threaded limitations of Redis, and here if we zoom in into a specific or like a single process of Redis, you can see that in its classical configuration, its main thread would be overloaded, but its other threads will be idle or just partly loaded, just because all the data store operations are executed on its main thread. Now, with Valkey recently, there are some improvements in this area, but still the main thread could become a significant bottleneck. And I just recently released a blog post comparing Valkey open source versus Dragonfly on the same hardware. And there we can see that with CPU-intensive applications, Dragonfly is much better than Valkey, and Valkey can still behave in a very inefficient manner for some operations, some common operations, I would say. Again, this diagram is presented on our site. We are talking about comparing a single Valkey or Redis instance to Dragonfly, and if we use just a single thread with its usual configuration, you can see that Dragonfly can be 25 times faster in terms of throughput and still have a very good latency. But lots of people asked me, what about still horizontal scale, which provides infinite throughput? And I just wanted to say that Dragonfly was never against horizontal scale. Like our main message was about vertical scale and its advantages, and that it provides stability and better cost efficiency. And here, for the first time, we can actually compare Dragonfly with horizontal scale against, let's say, Valkey with cluster mode, also horizontally scalable solution, and just compare it, both systems, and to see how they behave and what kind of value for dollar you can get from both systems. And for that, I'm going to first show Dragonfly Cloud. I would like to actually jump into demo and show lots of things, so probably do that now. And I want to showcase how Dragonfly behaves and how a Google memory store behaves, and we'll run both systems on Google Cloud, and we'll be able to compare them right now in real time. So let me just switch my sharing. Just a second, sorry. Okay, I hope you can see my screen, my shell. Let me switch to another tab. Yeah, so I already started a memory store with 20 shards. I started right before our talk, just because it takes 20 minutes to start a memory store cluster. And I used 20 shards with a total effective memory capacity of 208 gigabytes. And now I'm going to do the same with Dragonfly Cloud, and to showcase how simple it is to create equivalent cluster in our console. So I'm switching there. So here is our data store view. We don't have any data store here. I already connected and like networks and VPC peering and just handled it before. So now I'm creating a data store. And by the way, the same account on Dragonfly Cloud can be connected to 3 major clouds on AWS, GCP, and Azure. And we are present on almost all regions in each cloud. So now I'm creating a cluster. So Dragonfly Swarm, and I'm using a similar capacity, a bit less, and we'll talk about this. And since I'm going to compare throughput, I'm going to choose enhanced tier for my cluster. It's more CPU efficient with more CPU power, basically, for the same memory capacity. So I'm choosing enhanced, and I want to use VPC peering for that. Basically, that's it. And you can see that it costs $2,600 to have such a cluster with enhanced CPU abilities on GCP. So let's create it in US Central C, $2,600 a month. Okay, that's it. And in a few minutes, like 2-3 minutes, it's going to be active. And for now, I'm going to show how I'm going to test both systems, and I'll start with memory store. So basically, we are going to use our own load test program. It's called dfly bench. I hope my screen can be seen. And I'm going to run mset command with 5 keys, with kind of 5 random keys and random data, just to fill up each data store, each cluster. So I'm running this command in pipeline mode with maximum throughput on both systems, and I'll start with memory store. The value length for each value in this command is going to be 64 bytes. And so let's start. Just a second. Okay, it started running. Let me just verify that it runs right now. Yeah, we are filling up memory store cluster, as you can see. Here you can see that we have our current throughput and overall throughput. So here the number is around 2 million QPS for memory store with 20 shards. And you can see, so this number on the left is throughput at this very moment. And on the right here is the overall throughput that we have so far, average throughput. And you can see that the throughput on the left, so that just is sampled at that moment, is a bit spiky. So you have 1.4 million QPS here, and then it jumps to 2.3 million QPS, and then it goes down again to 1.6 million QPS, while the average throughput stays more or less the same, around 2 million QPS. So that's memory store that we are load testing right now. And our goal is to fill it up to its maximum until we see that it has errors, kind of out of memory errors, and then we'll stop the load test. Let's do the same with Dragonfly cluster. So it's already active. It took maybe 2 minutes to create, and I'm just using its endpoint. Okay, so it's empty, it's active, it's responding. Let's verify that we still have the same command here. Again, mset with 5 keys, the same load test I'm running against Dragonfly Swarm in pipeline mode, exactly the same parameters. Oh, sorry. Yep. Okay, so you can see here, I hope it's possible to see, our throughput is around 3.3 3.4 million QPS, so more or less 50% higher than of memory store. By the way, I showed how much it costs to launch Dragonfly Swarm of this capacity. Let me show you how much it costs 20 shards of memory store. So if you go back to memory store, this will show really quick how much it costs. So it's 20 shards of 13 gigabytes each without replica, no replication in this case. And it's $2,800, a bit more expensive. It's very similar cost, but let's see how they differ in terms of capacity and performance. So if I switch back to, memory store, we can see already that it has errors. It just responds with errors because it's full to maximum capacity. Let's check how much size do we get from this store. So it's around 66 million items in each shard, and we have 20 shards. So 20 multiplied 66. So we have 1.3 billion items in our cluster, a bit more, let's say 1.4 billion. And now, we are running. Now our Dragonfly Swarm also reached a maximum capacity. It also rejects any writes, so we can stop it now. By the way, you can see that its throughput stayed the same, around 3.2 million QPS, and its total number of entries. So you can see that it's around 230, I would say 37 per shard. So 237 items per shard, millions of items per shard, multiplies 8 shards, and we have 1.9 billion items in the cluster of equivalent capacity. So basically, with Dragonfly Swarm, we could put, let's say, 44% more items than with Valkey cluster. And we had 3.2 million QPS. Then we had, let me see, just before the error started. The overall, the average throughput was 2 million. So we used that. And we had 60% more throughput with a Dragonfly Swarm. And you can see that basically Dragonfly Swarm that costs cheaper than memory store with Valkey provides 60% higher throughput and 43% more capacity, effective capacity in the same, in equivalent cluster or in equivalent swarm. That's what I wanted to show. And again, if we will go back to our slides, to our presentation, basically the reason for that is the multi-threading, the vertical scale that Dragonfly provides. more efficient data structure that we have, and less waste due to metadata that Valkey needed to store for its data structures. I don't know if we have questions. I'll just proceed with slides. I hope this demo was interesting and educational. It's the first time that we kind of compare two managed service solution head to head. Just chose Google Cloud, but we could do the same with Amazon. Maybe we'll do it next time with Amazon as well. Just wanted to give you some sort of comparison, how much value you can get from the same, from the cluster that costs approximately the same or even cheaper on Dragonfly Cloud. So if we talk about Dragonfly Swarm, what are the main differences between Dragonfly Swarm and Valkey Cluster? So our technology doesn't have a centralized cluster bus, and everything is configured externally by our control plane. But if you look at the topology of the swarm, it's very much resembles same product or same configuration like with Valkey cluster. We have shards, and in each shard there could be primary nodes and replicas. And in case for some reason the primary node is not behaving well, the control plane automatically fails over to replicas. For caching scenarios, maybe replicas are not needed, and in that case, Dragonfly Swarm can operate without any replication, without high availability. And of course, high availability will cost double the cost, because we will need to double or triple number of nodes in our cluster. If we talk when we need to use Dragonfly Swarm, so basically right now in our product, Dragonfly standalone, or we call it emulated mode because it supports both cluster and single node clients. So it can support up to 400 gigabytes. The limitation is arbitrary. In fact, technology can support even higher workloads. We have customers and users running workloads on a single machine that reach 1 terabyte of data. Today we have hardware systems and servers that can reach even higher numbers. And in terms of QPS, again, in our load tests, we could reach even higher throughput. Sometimes, in perfect conditions, we can reach even 7 million queries per second on a single Dragonfly. Of course, I do not advise anyone to run such high throughput workloads on a single machine. But with Dragonfly Swarm, you can, of course, go to infinite capacity. And here again, we currently limit our product to 2 terabytes, but in our because what our customers need, but for our internal tests, we reach even 20 terabytes and higher workloads. With Dragonfly Swarm, you can also easily go beyond dozens of millions of queries per second. And again, it can even go higher than 100 million. Yeah, so with our managed service, what we provide, basically, you can easily reshard your cluster, increase number of shards, decrease Right now it's manual, but we're working on auto scaling, which will be released in this year, hopefully during summer. So we handle everything: rebalancing, resharding, high availability if needed. Basically, provide a seamless and very sleek experience. Maybe I can just try it now. Let me see. So in order to reshard, yeah, I can just choose, let's say, 250 gigabytes. Apply. Let's see what happens. By the way, this operation is very painful with any other in-memory service provider. It may take hours till your resharding will finish in the memory store or in the Elasticache. Very inconvenient, very painful, and it can really become an incident for teams that run workloads, and they need to scale up their clusters relatively quickly. With Dragonfly, it should happen in a matter of minutes, but we'll see. Yeah, any questions? I'll stop sharing. If there are no questions, I believe. Yeah, Laura?
No questions, Roman, you're good.
Okay, so I believe we'll be able to finish the presentation. Feel free to reach out to us on Discord. Also, if you sign up to Dragonfly Cloud, you'll be able to try it out and you'll get $100 in credits. Check it out. It's the best technology without a memory store without limits. And if you care about efficiency and scale, you should definitely check it out. Thank you all.